Hello. Hello. Here I go again. This will be, let me see if you can see everything correctly. Okay, yeah. This will be the third episode about GCP Cloud Fundamentals, core infrastructure. So I cannot speak. Now I will be better at pronouncing each word. Let's go. So last time I arrived at 34% of this course. I will go with the rest
In this
of
section
it
of the
today.
course,
From this video, you will be able to hear the audio I'm listening to. This way, you will not get bored with long silences, which happen many times.
we're going to explore how Google Compute Engine works with a focus on virtual networking.
So in this course, we already had the course introduction, an overview to the security, billing, and other principles. Then we had an introduction to the resources and the resources hierarchy. What do you want? Sorry, my friend wants to participate. So let's go. We need to continue today with the virtual machines and networks in the cloud. Please keep silence, or otherwise you just can go in another place. What do you think? Well. This is what you can say. Okay, let's go. So yeah, you can see me correctly. Let's go.
Many users start with Google Cloud by defining their own virtual private cloud inside their first Google Cloud project, or by starting with the default virtual private cloud. So, what is a virtual private cloud?
You're not leaving me other options. Okay, let's get back. Otherwise, I get distracted.
A virtual private cloud, or VPC, is a secure individual private cloud computing model hosted within a public cloud, like Google Cloud. On a VPC, customers can run code, store data, host websites, and do anything else they could do in an ordinary private cloud. But this private cloud is hosted remotely by a public cloud provider. This means that VPCs combine the scalability and convenience of public cloud computing with the data isolation of private cloud computing. VPC networks connect Google Cloud resources to each other and to the internet. This includes segmenting networks, using firewall rules to restrict access to instances, and creating static routes to forward traffic to specific destinations. Here's something that tends to surprise a lot of new Google Cloud users. Google VPC networks are global. They can also have subnets, which is a segmented piece of the larger network in any Google Cloud region worldwide. Subnets can span the zones that make up a region. This architecture makes it easy to define network layouts with global scope. Resources can even be in different zones on the same subnet. The size of a subnet can be increased by expanding the range of IP addresses allocated to it, and doing so won't affect virtual machines that are already configured. For example, Let's take a VPC network named VPC1 that has two subnets defined in the Asia East 1 and US East 1 regions. If the VPC has 3 compute engine VMs attached to it, it means they're neighbors on the same subnet, even though they're in different zones. This capability can be used to build solutions that are resilient to disruptions, yet retain a simple network layout.
Wow. Okay. So I had an idea about the VPC, but now I have a
Earlier in the
lot
course,
of
we explored
things I would like to understand. So let's see. GCP VPC, Virtual Private Cloud, global virtual network that spans all regions. Single VPC for an entire organization isolated within projects. Increase IP space with no downtime. Okay, start using VPC networks with these how-to guides. Network of 40 regions, 121 zones presence, blah blah blah. Okay. Use a single VPC to span multiple regions without communicating across the public internet. Learn more about what customers are saying about Google VPCs. VPC can automatically set up your virtual topology, configuring prefix ranges for your subnets and network policies, or you can configure your own. You can also expand CIDR ranges without downtime. VPC flow logs capture information about the IP traffic going to and from network interfaces on compute engine. These logs help with network monitoring, forensics, real-time security, and expense optimization. VPC flow logs are updated every 5 seconds. Okay. VPC peering, configure private communication across the same or different organization without bandwidth bottlenecks or single point of failure. Shard VPC, configure a VPC network to be shared across several projects in your organization. Connectivity routes and firewall associated are managed centrally. Bring your own IPs. Bring your own IP addresses to Google Network across all regions to minimize downtime during migration or reduce your network infrastructure costs. Okay, let's go to documentation. Okay, let's see if it's the same. No, creating a virtual network. Let's see. Extend on-premises network to Google with interconnect. Okay. Let's see. Packet mirroring VPN. Securely connect your existing network to VPC network over IPsec. Okay, so this is, I would say, the virtual private cloud introductory page. Then we have this create and manage VPC networks. This document describes how to create, modify, and delete virtual private cloud networks and subnetworks. Before reading this document, ensure that you're familiar with the characteristics of VPC networks as described in VPC networks. So is the same page we already read? No. Okay, so we'll get back to these. Networks and subnets are different resources in Google Cloud. Let me see. Okay, subnets. Okay. Virtual private cloud networks are global resources. Each VPC network consists of one or more IP addresses ranges called subnets. Subnets are regional resources and have IP addresses ranges associated with them. In Google Cloud, the terms subnet and subnetwork are synonymous. They are used interchangeably in the Google Cloud Console, Google Cloud CLI commands, and the API documentation. A network must have at least one subnet before you can use it. Auto-mode VPC networks create subnet in each region automatically. Custom mode VPC networks start with no subnets, giving you full control over subnet creation. You can create more than one subnet per region. For information about the differences between auto mode and custom mode VPC networks, see types of VPC network. Okay, so the main page will be this one. For now, I will keep them open, and yeah, I will just try to read these introductory paragraphs and then get back to the video. With these informations, I will be more capable of digesting the video. A virtual private cloud network is a virtual version of a physical network that is implemented inside of Google's production network by using Andromeda. What the fuck is Andromeda? Usenix, the Advanced Computing System Association. Andromeda is a performance, isolation, and velocity at scaling cloud network with virtualization. This paper presents our design experience with Andromeda, Google Cloud Product Network Virtualization Stack. Our production deployment poses several challenging requirements, including performance isolation among customer virtual networks, scalability, rapid provisioning of large number of virtual hosts, bandwidth, and blah, blah. Andromeda is designed around a flexible hierarchy of flow processing paths. Flow are mapped. Okay, so Andromeda is a software, a network virtualization stack. Let's see, GCP Andromeda. I don't know why this link attracted my attention. Okay, I will ask GCP Andromeda. Explain it in poor, simple words. Okay, I think that it's okay just to know that it exists, and maybe I will have some more information after. By the way, virtual private cloud network is a virtual version of a physical network that is implemented inside of Google's production network by using Andromeda. A VPC network does the following: provides connectivity for your compute engine virtual machine instances, offers native internal pass-through network load balancers and proxy system for internal application load balancers, connects to on-premises networks by using Cloud VPN tunnels and VLAN attachments for Cloud Interconnect. Distributes traffic from Google Cloud external load balancer to backends. Projects can contain multiple VPC networks unless you create an organizational policy that prohibits it. New projects start with a default network, an automod VPC network that has one subnetwork in each region. The term subnet and subnetwork, okay, virtual machine instances, specification. A compute engine virtual machine instance is a virtual machine that is hosted on Google's infrastructure. The term compute engine instance, VM instance, and VM are synonymous. They are used interchangeably in the Google Cloud Console. Blah, blah, blah. VM instance include JKey clusters, App Engine flexible environment, and Google Cloud Product build and other. VPC networks. Oh, okay. So when they say virtual machine instances, they refer to all types of computing resources, basically. VPC networks have the following properties. VPC networks, including their associated routes and firewall rules, are global resources. They are not associated with any particular region or zone. Subnets are regional resources. Each subnet defines a range of IPv4 addresses. Subnets in custom mode VPC networks. Subnet in custom mode VPC networks can also have a range of IPv6. Okay. Traffic to and from instances can be controlled with network firewall rules. Rules are implemented on the VMs themselves, so traffic can only be controlled and logged as it leaves or arrives to a VM. Resources within a VPC network can communicate with one another by using internal IPv4 addresses. Okay, for more information, blah, blah, blah. Network administration can be secured by using identity and access manager roles. Okay. So we'll start again this video here. I think
In this section of the course, we're going to explore how Google Compute Engine works with a focus on virtual networking. Many users start with Google Cloud by defining their own virtual private cloud inside their first Google Cloud project, or by starting with the default virtual private cloud. So, what is a virtual private cloud? A virtual private cloud, or VPC, is a secure individual private cloud computing model hosted within a public cloud, like Google Cloud. On a VPC, customers can run code, store data, host websites, and do anything else they could do in an ordinary private cloud. But this private cloud is hosted remotely by a public cloud provider. This means that VPCs combine the scalability and convenience of public cloud computing with the data isolation of private cloud computing. VPC networks connect Google Cloud resources to each other and to the internet. This includes segmenting networks, using firewall rules to restrict access to instances, and creating static routes to forward traffic to specific destinations. Here's something that tends to surprise a lot of new Google Cloud users. Google VPC networks are global. They can also have subnets, which is a segmented piece of the larger network in any Google Cloud region worldwide. Subnets can span the zones that make up a region. This architecture makes it easy to define network layouts with global scope. Resources can even be in different zones on the same subnet. The size of a subnet can be increased by expanding the range of IP addresses allocated to it, and doing so won't affect virtual machines that are already configured. For example, let's take a VPC network named VPC1 that has two subnets defined in the Asia East 1 and US East 1 regions. If the VPC has 3 Compute Engine VMs attached to it, it means they're neighbors on the same subnet, even though they're in different zones. This capability can be used to build solutions that are resilient to disruptions, yet retain a simple network layout.
Okay, so it's basically allowing modularity in the configuration of each machine's networking configuration. Okay, so it's decoupling. all the security and routing necessities between all machines and scopes. So you basically have modular, a modular framework where you can divide your resources by scope, by type of access you want to grant to people. Okay. So you can keep this separated from the public internet, and internal separation between projects. This happens at a physical level or nearly physical. I'm not sure. I will need to study a bit more Andromeda and how VPCs are provided. But yeah, from a user point of view, I feel that is clear. I don't know all the use cases, but I feel like it's clear for me what they're useful for. I would like to understand more how it's engineered, all the system.
In the course, we explored Infrastructure as a Service, or IaaS. Now let's explore Google Cloud's IaaS solution, Compute Engine. With Compute Engine, users can create and run virtual machines on Google infrastructure. There are no upfront investments, and thousands of virtual CPUs can run on a system that's designed to be fast and to offer. Earlier in the course, we explored infrastructure.
So this is a quick content about
Infrastructure as a Service, or IaaS. Now let's explore Google Cloud's IaaS solution, Compute Engine.
So IaaS, it's infrastructure.
Earlier in the course, we explored Infrastructure as a Service, or IaaS. Now let's explore Google Cloud's IaaS solution, Compute Engine. With Compute Engine, users can create and run virtual machines on Google infrastructure. There are no upfront investments, and thousands of virtual CPUs can run on a system that's designed
and thousands of virtual CPUs can run systems that is designed to
be fast and to offer consistent performance. Each virtual machine contains the power and functionality of a full-fledged operating system. This means a virtual machine can be configured much like a physical server by specifying the amount of CPU power and memory needed, the amount and type of storage needed, and the operating system. A virtual machine instance can be created via the Google Cloud Console, which is a web-based tool to manage Google Cloud projects and resources, the Google Cloud CLI, or the Compute Engine API. The instance can run Linux and Windows Server images provided by Google, or any customized versions of these images. You can also build and run images of other operating systems and flexibly reconfigure virtual machines. A quick way to get started with Google Cloud is through the Cloud Marketplace, which offers solutions from both Google and third-party vendors. With these solutions, there's no need to manually configure the software, virtual machine instances, storage or network settings, although many of them can be modified before launch if that's required. Most software packages in Cloud Marketplace are available at no additional charge beyond the normal usage fees for Google Cloud resources. Some Cloud Marketplace images charge usage fees, particularly those published by third parties with commercially licensed software, but they all show estimates of their monthly charges before they're launched. At this point, you might be wondering about Compute Engine's pricing and billing structure. For the use of virtual machines, Compute Engine bills by the second with a 1-minute minimum, and sustained use discounts start to apply automatically to virtual machines the longer they run. So for each VM that runs for more than 25% of a month, Compute Engine automatically applies a discount for every additional minute. Compute Engine also offers committed use discounts. This means that for stable and predictable workloads, a specific amount of vCPUs and memory can be purchased for up to a 57% discount off of normal prices, in return for committing to a usage term of 1 year or 3 years. And then there are preemptible and spot VMs. Let's say you have a workload that doesn't require a human to sit and wait for it to finish, such as a batch job analyzing a large dataset. You can save money, in some cases up to 90%, by choosing preemptible or spot VMs to run the job. A preemptible or spot VM is different from an ordinary Compute Engine VM in only one respect. Compute Engine has permission to terminate a job if its resources are needed elsewhere. Although savings are possible with preemptible or spot VMs, you'll need to ensure that your job can be stopped and restarted. Spot VMs differ from preemptible VMs by offering more features. For example, preemptible VMs can only run for up to 24 hours at a time, but spot VMs don't have a maximum runtime. However, the pricing is currently the same for both. In terms of storage, Compute Engine doesn't require a particular option or machine type to get high throughput between processing and persistent disks. That's the default, and it comes to you at no extra cost. And finally, you'll only pay for what you need with custom machine types. Compute Engine lets you choose the machine properties of your instances, like the number of virtual CPUs and the amount of memory, by using a set of predefined machine types or by creating your own custom machine types.
Okay. So just one second.
As we've just seen, with Compute Engine, you can choose the most appropriate machine.
I have a resource I want to check if it's useful in cases like this. So the resource I was mentioning is this one. So it's not mentioning. Yeah, so okay, I will tell you. This material was made by a guy studying for the same professional architect certification I would like to achieve, and he created yeah, this cheat sheet. I was convinced he was mentioning also the difference between compute engine, custom VM, and all these cases that were mentioned in the video here. So
Earlier in the
I
course,
will
we explored
go and
infrastructure as a
look
service.
for specific
As we've just
information.
seen, with Compute Engine, you can choose the most appropriate.
Okay, so VPC networks, I had a look at them. I will look them again. I've seen that there is a lot to see. Then GCP, VMs, spot, VS preemptible. What are the key differences? Spot VMs. This page describes spot VMs. Okay. And preemptibles. What? What is no longer supported? What? Spot VMs are the latest version of preemptible VMs. New and existing preemptible VMs continue to be supported, and preemptible VMs use the same pricing model as spot VMs. However, spot VMs provide new features that preemptible VMs do not support. For example, preemptible VMs can only run for up to 24 hours at a time, but spot VMs do not have a maximum runtime unless you limit the runtime. To learn how to create preemptible instance, okay. So this is preemptible, much lower price, blah, blah, blah. Yes, location. Okay, if your apps are fault tolerant and can withstand possible instance preemptions, then preemptible instances can reduce your compute engine cost significantly. For example, batch processing jobs can run on preemptible instances. If some of those instances stop during processing, the job slows but does not completely stop. Preemptible instances complete your batch processing task without placing additional workload on existing instances and without requiring you to pay full price for additional normal instances. Preemptible have the following limitations. Compute engine might stop preemptible instances at any time due to system events. Compute engine always stops preemptible instances after they run for 24 hours. These are finite compute engine resources, so they might not always be available. Okay, so you cannot migrate or restart them automatically in case of maintenance event. They are excluded from Compute Engine SLA. And you cannot use your Google Drive free tier credits for these type of machines. Okay, therefore, the provisioning model of a VM affects its discount and viability. Compute engine VMs can use either, oh shit, sorry. hitting continuously my camera. Okay, here we are back in business again. The provisioning model of a VM affects its discount and availability. Compute engine VMs can use either the standard provisioning model, standard VMs default, or the spot provisioning model. In contrast to standard, spot VMs are available at much lower prices but have lower availability because they are subject to preemption. Use spot VMs to reduce cost for fault-tolerant workloads. To learn more about Compute Engine VM in general, read the virtual machine instances documentation. Okay, what are spot VMs? Might preempt spot VMs at any time, such as one needs to resolve other tasks. At this uncertain preemption time, Compute Engine either stops or deletes your spot VM depending on your specified termination action for each spot VM. Values, okay. If your workload are fault tolerant, can withstand, okay. Compute Engine might preempt spot to reclaim the resources at any time. The probability that Compute Engine preempts spot VMs is generally low, but might vary from day to day. They may not be always available, can't live migrate or automatically restart. Not covered by SLA, and they're only available for supported machine types. And what about them? Okay. All machine series support spot VMs with exception for the M2, M3, and X4 machine series and C3 bare metal machine types. This is a list of Compute Engine machine families. For a detailed explanation of each machine family, see the following page. Okay. Let's go.
As we've just seen, with Compute Engine, you can choose the most appropriate machine properties for your instances, like the number of virtual CPUs and the amount of memory, by using a set of predefined machine types or by creating custom machine types. To do this, Compute Engine has a feature called autoscaling, where VMs can be added to or subtracted from an application based on load metrics. The other part of making that work is balancing the incoming traffic among the VMs. Google's Virtual Private Cloud, VPC, supports several different kinds of load balancing, which we'll explore shortly. With Compute Engine, you can in fact configure very large VMs, which are great for workloads such as in-memory databases and CPU-intensive analytics. But most Google Cloud customers start off with scaling out and not up. The maximum number of CPUs per VM is tied to its machine family, and is also constrained by the quota available to the user, which is zone-dependent. Specifications for currently available VM machine types can be found at cloud.google.com/compute/docs/machine-types.
Okay, yeah.
Now let's explore some of the most important virtual private cloud compatibility features. Much like physical networks, VPCs have routing tables. VPC routing tables are built in, so you don't have to provision or manage a router. They're used to forward traffic from one instance to another within the same network, across subnetworks, or even between Google Cloud zones, without requiring an external IP address. Another thing you don't have to provision or manage for Google Cloud is a firewall. VPCs provide a global distributed firewall, which can be controlled to restrict access to instances through both incoming and outgoing traffic. Firewall rules can be defined through network tags on Compute Engine instances, which is really convenient. For example, you can tag all your web servers with, say, web, and write a firewall rule saying that traffic on ports 80 or 443 is allowed into all VMs with the web tag, no matter what their IP address happens to be. You'll remember that VPCs belong to Google Cloud projects. But what if your company has several Google Cloud projects, and the VPCs need to talk to each other? With VPC peering, a relationship between two VPCs can be established to exchange traffic. Alternatively, to use the full power of Identity Access Management, IAM, to control who and what in one project can interact with a VPC in another, you can configure a shared VPC.
Okay.
Previously, we explored how virtual machines can autoscale to respond to changing loads. But how do your customers get your application when it might be provided by 4 VMs one moment and by 40 VMs at another? That's done through cloud load balancing. The job of a load balancer is to distribute user traffic across multiple instances of an application. By spreading the load balancing reduces the risk that applications experience performance issues. Cloud load balancing is a fully distributed, software-defined managed service for all your traffic. And because the load balancers don't run in VMs that you have to manage, you don't have to worry about scaling or managing them. You can put cloud load balancing in front of all of your traffic, HTTP or HTTPS, other TCP and SSL traffic, and UDP traffic too. Cloud load balancing provides cross-region load balancing, including automatic multi-region failover, which gently moves traffic in fractions if backends become unhealthy. Cloud load balancing reacts quickly to changes in users, traffic, network, backend health, and other related conditions. And what if you anticipate a huge spike in demand? Say your online game is already a hit. Do you need to file a support ticket to warn Google of the incoming load? No. No so-called pre-warming is required. Google Cloud offers a range of load balancing solutions that can be classified based on the OSI model layer they operate at and their specific functionalities. Application load balancers operate at the OSI model layer they operate at.
Application load balancer. So it's a set of rules working at layer 7 of the OSI architecture.
And their specific functionalities.
Network load balancer will be a set of rules working at IP protocols level.
Application load balancers operate at the application layer and are
They can be both external, internal, global, regional, global, external application load balancer, or for example, regional, internal application load balancer.
designed to handle HTTP and HTTPS traffic, making them ideal for web applications and services that require advanced features, like content-based routing and SSL TLS termination. Application load balancers operate as reverse proxies, distributing incoming traffic across multiple backend instances based on rules you define. They are highly flexible and can be configured for both internet-facing, external, and internal applications. Network load balancers operate at the transport layer and efficiently handle TCP, UDP, and other IP protocols. They can be further classified into two types. Proxy network load balancers also function as reverse proxies, terminating client connections and establishing new ones to backend services. They offer advanced traffic management capabilities and support backends located both on-premises and in various cloud environments. Unlike proxy network load balancers, pass-through network load balancers do not modify or terminate connections. Instead, they directly forward traffic to the backend while preserving the original source IP address. This type is well suited for applications that require direct server return or need to handle a wider range of IP protocols.
There's a lot to know.
One of the most famous free Google services is 8888, which provides a public domain name service to the world. DNS is what translates Internet's host names to addresses, and as you might imagine, Google has a highly developed DNS infrastructure. It makes 8888 available so that everyone can take advantage of it. But what about the Internet's host names and addresses of applications built in Google Cloud? Google Cloud offers Cloud DNS to help the world find them. It's a managed DNS service that runs on the same infrastructure as Google. It has low latency and high availability, and it's a cost-effective way to make your applications and services available to your users. The DNS information you publish is served from redundant locations around the world. Cloud DNS is also programmable. You can publish and manage millions of DNS zones and records using the Cloud Console, the command line interface, or the API. Google also has a global system of edge caches. Edge caching refers to the use of caching servers to store content closer to end users. You can use this system to accelerate content delivery in your application by using Cloud CDN, Content Delivery Network. This means your customers will experience lower network latency, the origins of your content will experience reduced load, and you can even save money. After an application load balancer is set up, Cloud CDN can be enabled with a single checkbox. There are many other CDNs available out there, of course. If you're already using one, chances are it's part of Google Cloud CDN Interconnect Partner Program, and you can continue to use it.
Wow, okay, so they're just throwing content at us.
Many Google Cloud customers want to connect their Google Virtual Private Cloud networks to other networks in their system, such as on-premises networks or networks in other clouds. There are several effective ways to accomplish this. One option is to start with a virtual private network connection over the internet and use Cloud VPN to create a tunnel connection. To make the connection dynamic, a Google Cloud feature called Cloud Router can be used. Cloud Router lets other networks and Google VPC exchange route information over the VPN using the Border Gateway Protocol. Using this method, if you add a new subnet to your Google VPC, your on-premises network will automatically get routes to it. But using the internet to connect networks isn't always the best option for everyone, either because of security concerns or because of bandwidth reliability. So a second option is to consider peering with Google, using direct peering. Peering means putting a router in the same public data center as a Google point of presence and using it to exchange traffic between networks. Google has more than 100 points of presence around the world. Customers who aren't already in a point of presence can work with a partner in the carrier peering program to get connected. Carrier peering gives you direct access from your on-premises network through a service provider's network to Google Workspace and to Google Cloud products that can be exposed through one or more public IP addresses. One downside of peering, though, is that it isn't covered by a Google Service Level Agreement. If getting the highest uptimes for interconnection is important, using dedicated interconnect would be a good solution. This option allows for one or more direct, private connections to Google. If these connections have topologies that meet Google specifications, they can also be covered by an SLA of up to 99.99%. Also, these connections can be backed up by a VPN for even greater reliability. Another option we'll explore is Partner Interconnect, which provides connectivity between an on-premises network and a VPC network through a supported service provider. A Partner Interconnect connection is useful if a data center is in a physical location that can't reach a dedicated interconnect co-location facility, or if the data needs don't warrant an entire 10 gigabytes per second connection. Depending on availability needs, Partner Interconnect can be configured to support mission-critical services or applications that can tolerate some downtime. Cross-Cloud Interconnect helps you establish high-bandwidth dedicated connectivity between Google Cloud and another cloud service provider. Cloud service to support data transfer. Cloud Interconnect connections are available in two sizes, 10 gigabits per second or 100 gigabits per second.
Okay, so we have something practical. We'll exercise with a virtual lab. Getting started with VPC networking and Google Compute Engine. So VPC provides networking functionality Kubernetes and OpenJoin. In other words, without a VPC network, you cannot create a VM instance container. You cannot create VM instances, containers, or App Engine applications. Therefore, each Google Cloud project has a default network to get you started. You can think of a VPC network as similar to a physical network, except that it is virtualized with Google Cloud. A VPC network is a global resource that consists of a list of regional virtual subnetworks in data centers, all connected by a global wide area network. VPC networks are logically isolated from each other in Google Cloud. In this lab, you create an auto-mode VPC network with firewall rules and 2 VM instances. Then you explore the connectivity for the VM instances. Objectives. In this lab, you learn how to perform the following tasks. Explore the default VPC network. Create an auto-mode network with firewall rules. Create VM instances using Compute Engine. Explore the connectivity for VM instances. Setup and requirements. Start lab details. Okay. Open link in incognito. Okay. Task 1. Explore the default network. View the subnets. So each Google Cloud project has a default network with subnets, routes, and firewall rules. View the subnets. Okay, notice the default network of each subnets. Each subnet is associated with a Google Cloud region and private CIDR block for its internal IP addresses range and gateway. View the routes. Okay. Routes that VM instances and VPC network, how to send traffic from an instance to a destination, either inside the network or outside Google Cloud. Each VPC network comes with some default routes to route traffic among each subnet and send traffic from eligible instances to the internet. View the firewall rules. So we'll view the subnets, the routes, and the firewall rules. Delete the firewall rules, delete the default network, try to create a VM instance. Okay. Then create a VPC network and VM instances. Okay, so I will not be able to create a VM instance in the end here. Therefore, I will need to create a VPC network and VM instances inside that VPC network. Create a VM instance in a region which I will reveal after, will be revealed after. Create a VM instance in another region. Explore the connectivity for VM instances. Verify connectivity for the VM instances. So I will go to the VM instance, open an SSH to that VM. Then I will need to ping the other machine. You can ping in terms of firewall rule. Okay. Which firewall rule allows the ping to my address? Okay. Remove, review, and okay, 40 minutes. I think I will finish all of this in 20. What? Well, so start lab. Opening incognito this other. Okay. Just a second and I will be back showing everything. For now, I'm just logging in the virtual lab. Oh shit, it's showing me everything in Spanish. Okay. We can continue. Perfect. So now to show you the window capture. Yeah, it's this one. Perfect. Okay. Let's go. So, okay, I mean, you will be able to see this window only when I do like this. Okay. Not even in that case. Let's see if I do like this. Oh man. Okay, okay. We found out how we can work. Perfect. So task one, each cloud project has a default network. View the subnets. So I will go to VPC network, VPC networks, click default, click subnets. Notice the default network with its subnets. Notice the default with its subnets. Each subnet is associated, blah, blah, blah. Okay. Let's open all this stuff. VPC network, networks, default, subnets. Okay, we have all these subnets for all the regions. Region and the private CIDR block of internal IP addresses range. primary IPv4 range. Okay. Now, what's the rest? View the routes. In the left pane, click the routes. Effective routes, click network and select default. So routes, effective routes, network. Click region and select the lab region assigned to your quick labs. The fuck? The lab region. So my lab region, oh shit, is US East 4. US East 4. Okay. View. Okay, so these are our effective routes. What the fuck does this mean? Notice that there is a route for each subnet. These routes are managed for you, but you can create custom static routes to direct some packets to specific destinations. For example, you can create a route that sends all outbound traffic to an instance configured as a NAT gateway. So these are basically the paths to all our subnets. Okay, destination IP range. So these are the IP range corresponding to our subnets. Effective routes, select VPC region. Okay, so this is route type, static, destination, file. This route applies to all instances within the specified network. Okay, so now that we have seen all the routes, we need to view all the firewall rules. Each VPC network implements a distributed virtual firewall that you can configure. Firewall rules allow you to control which packets are allowed to travel to which destinations. Every VPC network has two implied firewall rules that block all incoming connections and allow all outgoing connections. Block incoming, allow outgoing. So in the left pane, click Firewall. Note that there are 4 ingress firewall rules for the default network. So firewall, and there are these firewall rules which say for these IP ranges, allow these protocols with the corresponding ports. They're all ingress. Okay. So you can SSH into So it says that apart from this, we have some implied firewall rules that block all incoming connection, allow all outgoing. Then on the block, we also have these exceptions, I think, if I'm not wrong. Now these four rules allow ingress traffic from anywhere and TCP traffic within the network. Delete the firewall rules. Select all the default network firewall rules, click delete. Okay, so I will select them all, delete, delete. So now I will not be able to send any type of packet to the machines in the default VPC. Delete the default network. Okay. So if I go to VPC networks, if I go to default, delete VPC network, default, deleting. Roots, notice there are no roots, no firewall rules. Well, I mean, I will not be able to filter, so how is this possible? Means it did not finish the default network deletion task. Yeah, sometimes even apparently simple tasks will take some time. Okay, successfully deleted network. So if we go now to the roots, we'll have no roots. I mean, we'll not be able to even select a network, so we'll not have no roots, no firewall rules. Okay, so if now we try to create a virtual machine, compute engine, VM instances, there are no instances at the moment. If we do create an instance, I'm not sure if this is still true. Create instance, create, go, accept default values and click create. Make sure fields are correct to continue. No. So in network interfaces, I mean, where is the issues thing? Go to issues. Oh, okay. So I will not be able to select the network here. Therefore, I will not be able to create machine. So cancel. Create a VPC network and VM instances. So we go again to VPC networks. Create VPC network for name type my network. Whoa, sorry. Okay, so here I will need to create a VPC network called my network. For subnet creation mode, click automatic. Subnet creation mode automatic. For firewall, select all available rules. These are the same standard firewall rules that the default network had. The deny all ingress and allow all ingress rules are also displayed, but you cannot check or uncheck them because they are implied. These two rules have a lower priority. So that the allow ICMP, custom RDP, and SSH rule are considered first. Okay, so allow custom. So I cannot check and check these two, which are the implied rules. Okay, so click create when the new network is ready. Notice the subnet was created for each region. Okay, so was okay. So my network was created, subnets. What? Okay, so it says explore IP ranges. The subnet was created for each region. These two subnets are those for which we have subnet. Ouch. Yeah, there will be some kind of project setting. If ever delete the default network, you can quickly recreate it by creating an outbound network as you just did. After creating the network, allow internal changes to allow custom firewall rule. After creating internal changes to allow custom firewall rule. Okay. Therefore, now we can create a VM instance in US East 4. So the instance will be called like this. Oh shit. The region is this one, the zone this one, the series E2, E2 micro. So E2, E2 micro. Create. Let's go. Now create a VM instance Asia East 1. Okay, so let's go. Okay. The same type of machine. Okay, so after that, the external IP addresses for both VMs are ephemeral. If an instance is stopped, oh, sorry, I just kicked the camera again. An ephemeral IP address assigned to the instance are released back into the general compute engine pool and become available for use by other projects. When a stopped instance is started again, a new ephemeral external IP address is assigned to the instance. Alternatively, you can reserve a static external IP address which assigns the others to your project and finally until you explicitly release. Okay, so check my progress. Great. Now, explore the connectivity for VM instances. Explore the connectivity for the VM instances specifically. Try to SSH to your VM instances using TCP/22 and ping both the internal and external IP addresses of your VM instances using ICMP. Then explore the effects of the firewall rules on the connectivity by removing the firewall rules individually. So the firewall rules that you created with my network allow ingress SSH and ICMP traffic from within my network and outside that network. So not the external and internal IP addresses. Okay. Therefore, I need to go to the second machine. I will take a sticky note. So internal IP is this one, external this one. Okay. For MyNet, click SSH to launch the authorize pop-up. Okay. So from this machine here, we go into SSH. You cannot see this if I don't share it with you. Okay, so now you can see it. Nice. So I will authorize this. Okay, so now we have this command line interface to this machine. So now we'll execute from this machine some connectivity tests to this other machine. Let me just reduce for a second. You can SSH because of the allow SSH firewall rule, which allows incoming traffic from anywhere. So this moment, we are SSHing from the home, how we call it. So each account, when going to the console, they have the cloud shell. So yeah, I have this cloud shell, which allows me to SSH into the machine. And as this guide was mentioning, I can do it through this protocol and this port because the firewall has a rule allowing it. Otherwise, if this rule was not existing, all the incoming packets on that protocol and that port will not be allowed to arrive to the machine. This is my take. This is going to work seamlessly because Compute Engine generates as escape or stores in one of the following location. Adds the generated key to the project or instance metadata. So the SSH connection works seamlessly because Compute Engine generates an SSH key for you and stores it in one of the following locations. By default, Compute Engine adds the generated key to the project or instance metadata. So if we go to the instance metadata, which for this machine, they shall be at the end. yeah, key enable OS login through, well, I'm not sure if this is the only information, but yeah, we basically can SSH into that machine because of that information. I think it's this one, the case. So if your account is configured to use OS login, Compute Engine stores the generated key with your user account. Yeah, we'll go better on this later. To test connectivity to my R2 VM, use internal IP, run the following command, replacing mynet, internal IP, okay. So it's ping C3. Okay, so ping minus C3, and here I will put the IP address, internal IP address of that machine, the other one. So I'm pinging, and 3 packets transmit received, 0 packet loss. Great. So it's working, the internal connection. You can ping because of the allow custom firewall role. To test external IP, blah, 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 try the same command, right? It's the same one, but with the external IP. Instead of that IP, we need this IP. Okay, and this is also working. So okay, so which firewall rule allows to the ping to my network and external IP address? My network allow SSH? No. ICMP, I mean, here you can ping my internal because of allow custom for a rule. Let me watch a bit to the firewall rules. PC network, my network, firewall rules. So remote desktop connection doesn't mean anything in this moment. ICMP is the one used for the ping. Type ingress targets all. So it's the same. No. Why it says allow custom? What protocol does ping use? Oh fuck. ChatGPT. What protocol is based on the ping command? Okay, So core protocols with okay, int minus C3 in Debian. What does this mean? The minus C. Okay, it's just a control about that. I have a VPC in GCP, a default one with implied with just 4 firewall rules other than the two implied ones. The 4 rules are about allow are for ICMP, RDP, SSH, and what was the other? Allow custom. What the fuck does this mean, allow custom? Custom protocols. Okay, so I'm not understanding. Why on earth? Oh shit, did they close? Man, I know, it's here. So why it's saying here, you can ping my internal because of allow custom firewall. What the fuck does this mean? I will say allow ICMP. Fuck you. So maybe there's any difference in case I am using internal IP or external. When to use internal API are used to between resources within the same VPC or between. Okay, firewall rule consideration. The source center must be connectivity within the VPC. The ACMP should permit traffic for the source internal range. Traffic between instances using internal IP does not target the public internet. Okay. If both instances are in the same VPC and the ACMP rule allows traffic, okay. Wow. Oh my God, why it's saying here? You can ping. I mean, I will not continue in this. I will lose my head. I will get insane about this. I just think that this is an error. And I'm losing all my time here. So remove allow ICMP firewall rules. Oh, okay, now, yes, I think it can be. So if I go here, and delete this, shall I delete it? Remove, okay, firewall. Select my network ICMP rule, delete it. My network ICMP, okay. Now, return to the SSH terminal for that machine, okay. And what should I do? Ping again with the internal and the external. Okay, with the internal, it will work again. Perfect. With the external, it should not work. Oh, great. Okay. Now it's saying, oh, fuck me. Now it's saying here it was working because allow custom firewall rule. Here it's not working because the only way to contact through external IP was with allow ICMP. I'm curious even more now. I mean, IP ranges, okay. So for example, okay, because these have 000, so the protocols have 000. I imagine also ICMP. In this case, it has only an internal IP range, not 000. Okay, I see now. Maybe this was the case. Let's go. Remove all custom firewall rules. Oh, I know. Allow custom. Okay, so I will not be able even through internal IP. Okay. Let's just do this stupid test here. Okay, delete. Now, if I go here, not even the internal will work. Great. So now I just connect it. And here I have 3 minutes left. Remove all allow SSH firewall rules. I will not be able to SSH. Reviewing this lab, you explore, you deleted the full network, then you created a new automod VPC in every subnets, then you tested the connectivity, blah, blah, blah. We'll delete this so in case they check for the points. Man, the points. Let's go. Okay, now I can do end lab. So it took for a solid 40 minutes to have this simple lab, even if I was thinking to do it in 20 minutes. But yeah, let's go anyway. Next. So I have a lot of points now. I have 4 question quiz. Google Cloud VPC, what scope do subnets have? So now. Oh, fuck. Man. Regionals. Sorry, I have to check. VPC, GCP. Okay, so subnetwork. Okay, a subnet is not the same. Virtual machine instances, specifications. Okay, so subnet. So it's regional. Yeah, because VPCs are global, the subnets are regional. How does cloud load balancing allow you to balance HTTP-based traffic? How does across multiple Google Cloud platform services, across multiple physical machines in a single data center, across multiple virtual machines instances in a single computer engine region, across multiple compute engine regions. For which of these interconnect options is a service level agreement available? Oh, fuck, this could be also right. Because it's not only compute engine. Yeah, you can redirect traffic to different things, not only compute engine. For which of these interconnect options is a service level agreement available? Dedicated, yes. What is the main reason customers choose preemptible VMs to reduce cost? Let's see. Oh, fuck, I failed it. Yeah. So VPC subnets are regional, okay. Expanded zone that make up a region is beneficial because they operate fault tolerance without completing your network topology. How does cloud load balancing allow you to traffic across compute engine regions? Cloud load balancing. Oh, dedicated interconnect to reduce cost. Man, tell me I did it right. Okay. Okay, next one. So we finally did it. We finished.
Every application needs to store data, like media to be streamed or perhaps even sensor data from devices. And different applications and workloads require different storage.
Okay, so this will be the section. This section will be for the next video. We have still a long course here, but we're already at the 53% of it. Let's see the situation here. So we have 5 days remaining. We can get promoted to the Gold League, but yeah. Let's see if tomorrow we can do it. I hope these people here do not make too many points during my resting time. Let's see. So I will close for today. I'm really happy of my progress. I hope this can be useful also for you, and let's improve.